I'm Anil Kumar, sharing with you another interesting thing which you should know before doing the chapter on functions or advanced functions, and that is completing squares method. We use completing squares method to write a quadratic equation given in standard form into the vertex form. What I'm trying to say here is that if I'm given equation as y equals to ax squared plus bx plus c, and if I have to write this in equation in the form of a times x minus b whole square plus q, that is called the vertex form. In that case, we'll need completing the squares method. Now, why is it important to write in this form? In this form, we can easily sketch the graph, right? And explain transformations. So these are two major advantages of writing equation in completing the squares method, and in many applications we could find maximum or minimum value as the case may be, right? So optimization problems can be solved. So that is why it is a very, very important tool to have, right? So it is important to understand how to convert any quadratic equation for that matter into the vertex form. Generally, the method uses completing squares. So let me take up an example just to review what we had learned earlier. So let's write down equation as y equals to 2x squared plus 6x minus 5, right? To complete this squares, first we should only consider these two x terms and take coefficient of x squared as common. So 2 is taken common, I use square brackets. X squared plus 6 divided by 2 is 3, so we have 3x. Close this bracket. Keep this third term separate. Now, we have x squared plus 3x. If you remember, what is a plus b whole square equals to? A plus b whole square is equals to a square plus 2ab plus b square. So that is a perfect square. In case we want something like this, we need to have three terms where two are perfect squares and the center term is twice product of these two. Now here we have a perfect square, we have 3x, that is our center term. We will like to make this as twice ab, and we will introduce b square, that is completing the squares method. Let us see how we can do it. So what we do here is we write this as x squared plus 3x. We add and subtract half of this number, so that it becomes twice this number, right? So we add and subtract half of this number, which is 3 over 2, kind of square of that. So this is b squared, do you see that? And we subtract the same number also. So when you add and subtract same number, you're not changing the equation. It remains exactly the same. But there is a major change which has happened, and that is these three terms now are like this, and we could write them as a perfect square. Since we have plus here, we'll use x plus 3 over 2 whole square, and there we'll expand this, which is minus 3 square is 9, 2 square is 4, minus 5. You get an idea. So this step is kind of critical while completing the squares, and that gives the name completing the squares. We introduced two terms, right, whose addition is 0. So it doesn't make a difference in the equation, but it helped us to complete a square. So now we can open the bracket. Let me do it on the right side. So we open the bracket, so we can write this as 2 times x plus 3 over 2 whole square minus 2 times 9 over 4 minus 5. That is equals to 2 times x plus 3 over 2 whole square minus, that is 9 over 2, right? So it is 9 over 2 minus 5. Let me write them in decimals. You could also write in fractions, right? So it is 2 times x plus 1.5 minus, this is 4.5, right? So half of 9 is 4.5, so that is 9.5 as a result. Well, you could have written in fractions also, which is minus 19 by 2, right? So you could also write this as minus 19 by 2. That's okay. So either way. But anyway, once you write the equation in the vertex form, we know what the vertex is and the characteristics of this quadratic equation. This vertex is at the point whose x value is minus 1.5, whatever makes this 0, and minus 9.5 is the y value for the vertex. Now since it has positive coefficient, the parabola represented by this opens upwards, kind of like this, and therefore the vertex represents a minimum. So the minimum value is minus 9.5 and the axis of symmetry is at minus 1.5. So you get a lot of information from this particular equation that helps to answer all these questions and also explain transformations, right? To graph, once we get the vertex, we can sketch the graph by following the steps. So let me add that also, as it may be required. So steps normally are 1, 3, 5, 7 and so on times the a value. A value is 2, which remains same, times a value of 2. So those are the points. From the vertex, first step will be 2 times 1. So this value will be 2 times 1 higher, and then the next step will be 3 times 2, which is 6 steps. So next time you do go 6 up to get the next point. And from the symmetry, you can get all the points to sketch. I hope that really helps you to understand all the concepts and review what you had learned earlier. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.